We're talking about triangles here today, and we're going to start with the elements of a triangle. Right? Now, a triangle has many parts, as you can see, right? And we just normally name, first of all, the points. The points we will name in capital letters. So we have the point A and we have the angle A. Yeah? We have the point C and we have the angle C, and those are capital letters. The point B and the angle B. Okay? But if you look opposite the point B, opposite the angle B, you will see the side which is in common letters, B. Yeah? If you look opposite the point A or the angle A, you will see the side A which is in common letters. And if you look opposite the point C, you will see the common C for the side. Did you know that the sides were common letters and the angle and points were capital letters? Now I have a question. I could have called this XYZ. Why did I choose to name the opposite side with the same name as the opposite angle to it? So why did I do that? Why? Why didn't I just name this one C? Yeah? Why is the side A corresponding with the opposite angle? Why? Why did I choose to name this side A? Yeah? Why? Shazay, any idea there? What does this opposite side have to do with this angle? Well, think about it, right? Let me look at this half a triangle down here on the side here, if you see it, right? We have this small angle A, right? And if the angle A gets bigger, doesn't this side over here get longer? Would you agree?
Yes, sir.
If the angle A gets smaller and this side here gets smaller, and
Yes, sir.
so the side that is opposite is dependent on the angle. The bigger the angle, the bigger the side, and
Yes, sir.
right. So that is why if this angle is A, the opposite side will be the side A, because this side A is the length of that side is dependent on how big that angle is. You understand, Scotia?
Yeah.
Right? Cool stuff, right? Nice. So we're starting from scratch here and we're going along, right? And of course, you know the points are called, this point is a vertex. It's also called vertices, right? So now we talked about the elements of a triangle, and I think everybody here kind of knows the types of the triangle, right? And we have a little better view of it here in terms of the types of a triangle. Right? Now the equilateral has 3 equal sides and 3 equal angles. And this equilateral will always be 60 degrees. So think about it. If this side has this length, this side is determined by this angle. So if this side over here have the same length, that means that this angle over here had to be the same. And if this side over here have the same length, that means that this angle over here have to be the same. So when all three angles are the same is 180 divided by 3, right? Which is 60. So Shazay, you okay with this, right? Yeah? Now,
Yes, sir.
same thing over here. If this side is governed by this angle, then this side being the same length means that this angle will also be the same. So when we're talking about an isosceles triangle, only two of the sides are the same. And that means that the two base angles will be the same, right? So that is your isosceles triangle. And then we have the crazy triangle, right? Which is the scalene triangle, where we don't have any equal sides, we don't have any equal angles at all. Everything is all just a mess, right? It's all just craziness in there. We could also classify triangles by the angle. So we have the acute triangle, right? We have the right angle triangle, right? And we have the obtuse triangle, who is greater than a right angle, greater than 90. And this is where you're going to have to kind of remember a lot of stuff. It have a lot of triangle theorems, right? So Scotia, I'm sure you know this first one. Could you explain to me what this first one is saying? So this is the first theorem, the interior angles add up to 180. So the second theorem is what we were talking about all the time. That the longest side of a triangle is always opposite the largest angle. And we were just talking about that. How the longer the side, the bigger the angle opposite. That the opposite side is determined by the angle opposite to it. So theorem 2 is the longest side is always opposite the biggest angle. And we know in a right angle triangle, sorry, you were saying something? Somebody was saying something? In a right angle triangle, the longest side is always the hypotenuse, right? And it is opposite the largest angle, which is the right angle 90. Because inside of a triangle is 180, which means that these two need to add up to give you an next 90 to get the 180. So therefore, this will always be the largest angle in a right angle triangle, right? If it is that I was to draw this, extend this side into a straight line, wouldn't this be 180 degrees? Yeah?
Yes, sir.
And if this is 180 degrees, what if I take off this angle here? Yeah? Then I will just have this left, and yeah? And that's all that I would have left, right? I would just have this left. But similarly, and the three angles inside this add up to 180 degrees. So if I cut this angle out from it, I would just have these two left. And since we're cutting the same angle out, that means that this outside angle has to be equal to these two angles on the inside. Isn't this 180 degrees?
Yes, sir.
Right? So if I cut this angle out, I would just be left with this section over here.
Yeah.
Right? So this section will be 180 minus that C, and
Yes, sir.
right. But and all the three angles inside is also 180 degrees.
Yeah.
So if I cut out the same C, then these two angles are going to be 180 minus the C, and
Oh, yes, sir.
so therefore these two angles together is the same as this one outside here. We have theorem 4. The sum of all of the exterior angles will add up to 360 degrees. The sum of all of the exterior angles will add up to 360 degrees. real easy little questions here that have answers in them, and I don't know why, right? And I think that these questions are really simple. How to find x? Tell me real quick how to find x. Find x and then find x and y in this one. You have 2 minutes. The first one is, you see in here that we have interior angles add up to 180 degrees. So 32 plus 24 is 56. So therefore x will be 180 minus 56. Anybody have an answer for that? 124. 124?
Yeah.
Alright. What about this one? How do we work this one out?
Minus 292 from 180.
To get y.
Yeah.
And where's y? 88?
Yeah.
88. And therefore you can do the interior angles thing to get x. And where's x?
42.
42. Shazay, you okay?
Yes, sir.
Caitlin, we are doing angle theorems here. We just covered 4 angle theorems. Remember, the class is recorded, so you can always go back and check the video when it's uploaded, right? Now, we're gonna talk about congruent triangles. Anybody want to explain to me what is this whole congruent triangle business about? Congruent triangles simply mean 2 triangles are the same. That's all. So if 2 triangles are the same, then they are congruent. You understand?
Yes, sir.
It really is that simple. It doesn't have to be more complicated than that. If 2 angles are the same, they are congruent. And even though you probably thinking, well, I was saying the same thing if they have the same angles and thing. Well, it's true. If 2 triangles are the same, then they would have the same angles and the same sides. But look at the 2 triangles I have in the diagram here. Can you prove that they are the same? How would you, if I told you to prove that these 2 angles are the same, how would you do that? Very good. One way is measuring. You can measure the sides and you can measure the angles, eh? Right. So it have 4 different ways to check and see if 2 triangles are the same. The first way is if they have all the same sides, right? So you see here we have SSS. Right? So if you measure this side, it's the same as this side, the corresponding side in the other triangle. You check this side and it's equal to this side, and you check this side and it's equal to this side. Well, then these 2 triangles are the same. You understand?
Yes, sir.
Yes.
Right? Now this is just one way, side, 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 right? And trust me, it might seem easy, but when the questions hit you, right? Then we have another way. Oops, sorry. When I was teaching my form trees this before, right? Is if we have the 2 sides and the angle between them. And if that is the same as this side, and the angle between them. So therefore this side is the same as this side. This side is the same length as this side, and this angle between them is the same. Then they are both the same triangle. You understand?
Okay.
So side, angle, side is the second way. The third way is angle, angle, side. Now all of this is real obvious, you know, because if this angle is the same as this angle, wouldn't that tell you that this side would be the same as this side? Yeah? Especially if these 2 sides are the same as well. Yeah? So similarly, we can have two angles and the adjacent side between them. So this angle is the same as this angle. This angle is the same as this angle. So that means that this side and this side will automatically be the same because the opposite angles are equal. Same with this side, and this side will be the same because the opposite sides are equal. Right? But then the side that is adjacent, this side that touching both of the angles, that side is equal. So if this side is equal and the two angles are equal, angle, side, that is the third way to check congruence. And let me know if I'm going too fast there, because you all should be making all of these notes. Remember, this is a summary of the entire topic of triangles here. So it's a very valuable notes to have, right? So let me know if I'm going too fast. And the fourth way to check congruence has to do with the right angle triangle. If you have two triangles and they both have 90-degree angles in them, they both have the same hypotenuse, and then any one of the corresponding sides are equal, then they are the same triangle. Are these two guys congruent?
Yeah.
The thing is that they're telling me that this angle is the same as this angle, right? Which means that this side is the same as this side, right? But all they give me is an angle and a side. That's two things. I don't have enough here. I need three things. Either another angle must be the same, or another side must, well, I'm not going to write the other side, I'll write the other side over here, right? Another side must be the same. You understand? So no, these two are not congruent. So you're seeing here that, you know, right angle, hypotenuse, and a side. Yeah? So that is three things. Yeah? You're seeing here two angles and a side. You're seeing here two sides and an angle. You're seeing here three sides. So you see it's always three items that we need. You understand?
Yes, sir.
Right. So moving on. This is a nice little one, right? A nice little thing to know about equilateral triangles and isosceles triangles, right? Is that if it is you was to take any vertex and you cut a line that going perpendicular to the opposite side, right? What you are actually doing is you are bisecting the triangle. So this side will be equal to this side, which means that we have two congruent right angle triangles here. Same thing with the isosceles. With the isosceles, and imagine this angle, you know, is an equilateral. So this is 60, this is 60, and well, you know, this is 60, which means that if we bisect it, this is going to be 30 and 30 over here. Yeah. So we now have two right angle triangles that are congruent. Similarly over here, if these two are equal, no matter what this one is, this one will just get split in half, and this side will be equal to this side. So if it is you drop from a vertex, from a point, you drop a perpendicular for an equilateral or an isosceles triangle, you'll actually cut the angle, the triangle exactly in half, and you'll get two congruent right triangles, if you would like, right? Now, can anybody look at this slide and explain to me what a similar triangle is, or what similar triangles are? Similar triangles are actually proportionate to one another. So yes, if they are similar, they'll have the same angles, but they don't necessarily have to have the same size, right? But they will be proportionate to one another. What that means is I could take this triangle, multiply it by 2, and I'm going to have this triangle. How does it work? The angles of both triangles are exactly the same. It is the sides that are multiplied by 2. So for example, let's just say this was 4 centimeters, this was 5 centimeters, this was 3 centimeters. Let me just say that, right? And we have angle ABC. If I take this and multiply it by a scale factor of 2, then the triangle will get bigger. This will be 6, this will be 10, this will be 8, and my angles will remain A, B, and C. Right? You understand similar triangles, guys? Pretty easy stuff, right? So, this is the similar triangles question. So let me see if you all could figure this out. 1 minute. Figure out X and Y. You are told outright that these two triangles are similar. This will be, you could see here that from the base, this is 4. They are similar, which means the angles will be the same. So therefore, this is 8. 4 times 2 gives me 8. So therefore, if they're similar, then 5 times 2 will give me 10, and 3 times 2 will give me 6. Yeah. Pythagoras had said, and by the way, the Semicircle Academy is named after Pythagoras. Right? So Pythagoras had said that if you take the square, draw a square on each side of a right angle triangle, must be right angle. This only works for right angle triangles. You have a right angle triangle, you have a square on each one of the sides and the hypotenuse, and you find the area of that square. So 3 3s are 9, right, centimeters, and 4 4s are 16 centimeters, 5 5s are 25 centimeters. What Pythagoras found is centimeters squared. Right? So therefore this is 3 squared, this is 16 squared, and he found that if you added them, you would actually get the hypotenuse squared. Not 16 squared, sorry, 4 squared. What are you doing, boy? A little bit correcting me. 4 squared, you would actually get the hypotenuse to the 4th power squared, right? So, do I really need to explain Pythagoras, or is everybody okay with it? Caitlin, how are you with this? This here is Pythagoras' theorem. A squared plus B squared is equal to C squared. And in terms of CSEC, this is everything that they want you to know. So we took a look at the elements of the triangle, and how they named the different parts of it. We took a look at the types of triangles and what does make them special. We took a look at triangle theorems. There are 4 theorems that we took a look at, right? Some of interior opposites, some of exterior angles. We took a look at congruent triangles and the ways that they are the same. And then we took a look at similar triangles and then Pythagoras' theorem. So this is almost everything you need to know about triangles. In geometry, we just did triangles. So if you didn't get any of the notes, the PDF is here with all of the notes. Right? So we have all of the notes here that you have access to, as well as these triangle questions here. So these are the triangle questions that you guys have to do. We have the congruency questions here. We have the similar triangles questions here, where you have to prove that the 2 triangles are similar. And then we have the Pythagoras theorem questions here. It's just 3 pages. The questions are not much. You should get past it pretty quickly, right? Now it really is very simple. At the end of the day, what he found, Pythagoras, is that if I have a right angle triangle, C is always the hypotenuse. The hypotenuse is always the longest side of a right angle triangle. So we always call C the hypotenuse. And we can call the other two sides A and B. I don't care who is A and who is B. But what Pythagoras saw is that for every right angle triangle, A squared plus B squared will always be equal to C squared. Right? So this is a good way to prove if a triangle is actually right angled or not. So the first set of question here asking you to prove if this triangle is right angled or not. Right? So how do you think we're going to do that, Shizzy? How can we prove that this triangle is right angle? Right, we use the Pythagoras theorem. But which side will be C?
9.
Yeah, because 9 is the longest side, and the hypotenuse is always the longest side. So we have Pythagoras theorem: A squared plus B squared equals C squared. So we see here that we have 6 squared plus 8 squared, because this will be AB and this will be C, and that will be 9 squared, right? So 6 sixes are 36 plus 8 eights are 64, and that is equal to 9 squared. 9 nines are 81. So 36 and 64 is 100. 100 does not equal 81, so therefore this triangle is not a right angle. You understand what's going on here?
Yes, sir.
Right? Can you tell me real quick if this one is a right angle triangle? I'll give you a minute to work it out. If it's a right angle triangle, it should abide by Pythagoras theorem. It's equal to C squared. So we see C squared is 13 because that is the longest side. So 13 squared. A squared is 5 squared plus 12 squared. 5 5s are 25 plus 144. And what is 13 squared?
69.
So 25 and 144 is 169. So yes, this is a right angle triangle. So you're cool with that?
Yes, sir.
The other kind of question you would be asked is a question like this. That's the one. Where you are asked to find the missing side. So in this case, we are told that the triangle is right angled. They tell us that. And we're asked to find this side. We can see this side is the hypotenuse, so that is C. We're being asked to find C. So we quote Pythagoras theorem. And then we say, well, all right, 4 squared plus 8 squared is equal to C squared. 4 4s are 16 plus 8 8s are 64 is equal to C squared. Where's 16 plus 64? 80. So therefore C squared is equal to 80. So if C squared is equal to 80, is that the answer? Right? So how do I find the answer from there?
Square root.
Yes, right? Shazay, you understand that?
Yes, sir.
So now C is equal to the square root of 80, which I believe is maybe 8.9-ish, somewhere around there. Right? So now 8.9 centimeters. You understand, Shazay?
Yes, sir.
Now, any single Pythagoras theorem questions that you come up with, that you come across, will either be one of these two. One of these two types of questions, right? Where you find a missing side, or you prove that a triangle is right angle. You understand?
Yes, sir.
Right? And as I said, Pythagoras theorem is a really, really simple little theorem. But you'll see how useful it is. We will be using it in many, many other topics, including coordinate geometry. So we just learned everything that there was to know about triangles. Now let's see everything that there is to know about quadrilaterals, and is not much, but for CSEC, this is all you're required to know, right? So, in terms of the elements of a quadrilateral, right, we have to know, first of all, that the corners here are your vertex or your vertices, and then this here, we call this the side. So now, this is how we name a quadrilateral, right? And at the end of the day, you'll notice we didn't name the sides in small, in little, using common letters. So unlike a triangle, we don't use common letters for the sides. If I want to refer to this side, I will call this side the side AB. Or I could even call it the side BA. This here is the side BB. Right? Whoa, wait, I do a piece of nonsense here. You see the piece of nonsense I do? So I'll put B here. And this is C. Right? So this here will be the side AC, and this here is the side CD. So you notice here that we don't actually have to name the sides. The sides are just named by their vertices. So really, with a quadrilateral, you use your capital letter at each vertex and a capital letter again for the angle. So everybody cool with the elements of a quadrilateral? Now, of course, there are the types of quadrilaterals. And we spoke about this already, so I don't have to spend too much time on it, right? But there are a couple of important things. Do you remember when I asked the question, is a square a rectangle or is a rectangle a square? Remember when I asked that question?
Yes.
What was the answer?
Think of the word square word.
But Caitlin, you want to help her out? Caitlin has no idea. Caitlin eating popcorn. She eating popcorn and watching Netflix. Caitlin, you there?
Yeah.
She's like, oh God, he calling me. Let me tell him a pause. She paused, she show. It take long to pause the show there again. What is a rectangle? A rectangle is a type of parallelogram. A rectangle is a parallelogram. So that means that the opposite sides are equal and parallel. And so the sign for parallel is the arrows and the equal sign is the strokes, right? So the opposite sides are equal and the opposite sides are parallel, right? Isn't that true for a square? That the opposite sides are equal and parallel, eh?
Yes, sir.
But what a square has that a rectangle doesn't have, what it is?
All four equal sides.
All 4 equal sides, right? Now a rhombus is also all 4 equal sides. Right? So a rhombus is if you take a square and twist it. Yeah? So what you'll find with a rhombus is that the opposite angles will be equal. These 2 angles are equal and these 2 angles here are equal. Now we'll see in the next slide, we'll actually see this in a little more detail. And you really need to know all of these little things. But what I want you to notice is the hierarchy here. A quadrilateral, well, a parallelogram is a type of quadrilateral. A quadrilateral is just a 4-sided figure. A parallelogram is a type of quadrilateral where you have the opposite sides being parallel. That is all. For a parallelogram, the opposite sides are parallel. What are the types of parallelograms? Well, you have 2 different types of parallelograms. You have the rhombus, where all of the sides are equal. Right? And then you have the rectangle, where only the opposite sides are equal and parallel, right? In a rhombus, all of the sides are parallel, the opposite sides are equal and parallel as well, right? But a rectangle, you have 90 degrees. Yeah, 90 degrees makes a rectangle, right? So you could see here that a square, because a rhombus, all sides are equal and opposite sides are parallel. Yeah, opposite sides are parallel. So a square also has all of these. A square, I have all sides are equal and opposite sides are parallel, just like a rhombus. So a square is really, really special. We could see here in the hierarchy of things, right, that a parallelogram is a type of quadrilateral. And we have two types of parallelograms. We have rhombuses, we have equal sides, and we have rectangles where the opposite sides are equal, but not necessarily all of them, right? But then we have a square. A square is a type of a rectangle, but a rectangle is not a square, right? A square is also a kind of rhombus because it has all of the things of a rhombus where all of the sides are equal and the opposite sides are parallel. But a square have 90 degrees. So a rhombus is not a square. Right? So we could see here the hierarchy of quadrilaterals. And you should probably try to know it. I hope you were trying to sketch it all the time. If not, you will see the PDF in your Google Classroom. Now here is where we gain a little more into detail with them. And all of these tiny little markings that you see in there are very important and they mean something. Right? They mean something. First of all, we have the trapezoid or the trapezium. And all you really have to remember here is that these two sides are parallel. And you notice I have that arrow there to tell to the arrow sign to show that it's parallel. And if they are parallel, then you could draw a perpendicular from one to the other. Right? Then we have an isosceles trapezium. Now the isosceles trapezium, you have the parallel sides here, this side here and this side here parallel. But the isosceles trapezium is where these two unparallel sides, well, they equal in length. Right? They equal in length. Now this is where angle properties that kind of come into play. Whenever you have parallel lines, I want you to remember that you have two parallel lines. You could treat this like a transversal, which means that the exterior angle here is alternate and equal to this interior angle over here. You all agree with that?
Yes, sir.
Right? So it's a lot of little things that you all have to pay attention to. And in this trapezium, we have these two sides parallel, and an isosceles trapezium, those two other sides are equal. In a parallelogram, and a way to pay attention to the symbology here. Right? Oh, by the way, in an isosceles trapezium, the two base angles are equal and the two top angles are equal. So these are real good diagrams to draw. These diagrams just really solidify all of the characteristics in a visual way. So we have here these two sides are equal and they're parallel. And then these green sides here are equal and they're parallel. So because of that, what you would find is You notice how, you know, it's slanting like this, eh? So wouldn't this side, this angle here be the same as this angle here? Would you agree with that? Because they're slanting with the same, and they're parallel, right? Right? They're slanting with the same slope, right? So this angle here would be the same as this angle here, right? But guess what? They're parallel. So we could treat this like parallel, like that, like a transversal. Which means that this angle here and this angle here would be the same. So we see here in a parallelogram, your opposite angles inside of a parallelogram are always the same. You see it here. This angle is the same as this one. Yeah? And this angle here is the same as this one. So the opposite angles in a parallelogram are always the same. And you could even use your angle properties of parallel lines to test it. In a square, well, we all know the deal with a square. All of the sides are equal, so they all have 2 strokes. You're seeing that there? All of the sides are equal. A square, you have 90 degrees all around. These 2 sides are parallel, and then these 2 sides are parallel. Right? The cool thing about a square is that if you cut the diagonals, right, like that and like that, the diagonals bisect. Diagonals bisect each other. The diagonals bisect each other. Right? So what does that mean? Well, that means that this here will be a center point. And this side will be equal to this side. And this side will be equal to this side. Right? And because we have a square, means that, well, oh gosh, all 4 of them will be equal. Right? All of them will be equal. Right? And since this side is equal, since this diagonal here is equal to this diagonal here, we have an isosceles triangle because these 2 sides are equal. So we have, when you cut diagonals, you'll get 4 isosceles triangles. And of course, they could be equilateral depending on what is the length of that there. But more usually they're isosceles. Rectangles, we have basically the same kind of thing going on, where the diagonals bisect each other exactly in the middle, where this side will be equal to this side, equal. Yeah? In a rhombus, we have an interesting thing that's kind of going on. Right? Remember, a rhombus is a twisted square. So all of the sides are equal. All of them. We have this opposite side being parallel to this opposite side. We have this opposite side being parallel to this opposite side. Remember, in a rhombus, just like a parallelogram, because a rhombus is a parallelogram, so your opposite angles will be equal. Right? And you could use your alternate angles rule with the transversal to prove that. The thing about a rhombus is that the diagonals will always cut each other, bisect each other perpendicular. So if you have a true rhombus and you draw the diagonals, you'll get 4 right angle triangles. They will be perpendicular and they bisect. So this side is equal to this side, and then this side is equal to this side. But you notice I use different equal signs. So not all 4 of them are equal. Yeah, this line, when it cut in half, into 2 equal halves. This line cut in half into 2 equal halves. They're all at 90 degrees, so you have the square in the middle. Yeah, and not only that, but the diagonals bisect the angles as well. So you notice that when the diagonal come in here, right, this angle is x and this angle is also x. So it split the angles into two equal smaller angles. And a kite is what we have last. And with a kite, you could see that the diagonals intersect at 90 degrees. And with a kite, and if you look back here at the last thing, you can see that a kite is not a parallelogram. Yeah? So the sides of a kite are not parallel. Right? However, with a kite, the adjacent sides are equal. And this side is equal to this side. And then these two sides on the wings of the kite are equal. These two angles there. So you can see that in this diagram, I have a hell of a lot of information in diagrammatic form. Yeah? And what the textbook did was the textbook put it out in a table and write it out into a long set of notes. But I wanted to put it in a diagrammatic form so that it don't take a long set of notes. You could draw it and have everything there. So you guys understand these properties of quadrilaterals?
Yes, sir.
Any questions about any of this? Caitlin, how you feeling about this stuff? Alright, nice. Well, we're almost done. So we have a couple of angle properties. And the first one is a real obvious one, that the angles inside of every quadrilateral will always add up to 360 degrees. And I think everybody here knows that. So that is one angle property. Another one is the external angles of every quadrilateral will also always add up to 360 degrees. And well, I know I'm moving on real fast, but we have our last one here. And the last one is always watch out for the alternate angles with parallel lines. Alright? Because I have a trapezium, these two sides are parallel. If I extended it, then you will have the parallel lines, and this side here will be the transversal. That means that this angle will be equal to this angle. Not only that, but that means that these two angles, this one here and this one here, will add up to 180 degrees. Yeah? And all of the rules when it comes to parallel lines and transversals will apply. So when it comes to the questions now, I just have some real simple quadrilateral questions here. You can see this first one is, some super simple ones. Shown below are three rhombuses. Find the size of each of the missing angles. Simple thing. We have some kites here. Find the size of the missing angles in the kites. Right? We have here just random quadrilaterals, and you have to find the size of each one of the missing angles. We have some crazy looking ones as well, right? But we have this external business, and you know what? We didn't do concave and convex, so I'm wondering if they give you this boy. Actually, yeah. Yes. Yeah, you could do everything here. Yes, you can do everything here, right? Find the size of each missing angle. It's just a bunch of angles you have to find. Below are three trapezia. Find the size of the missing angles. I mean, it's easy. Just find some angles and you're good to go. Nice? So next class, we'll be doing these questions on triangles and the questions on quadrilaterals.